Okay, so I'm going to attempt to teach you two objectives from Chapter 6. And the first one is converting Celsius to Kelvin, which is fairly simple, but you're going to use it in all of your laws in Chapter 6. You can't do the math with Celsius, you have to convert it first. So, how they found this out was you have to first make a graph of temperature and volume, and if you extrapolate your line, it'll hit somewhere, and they all hit at negative 273, which is absolute zero. And this converts to the Kelvin scale as 0. So, if you want to change Celsius to Kelvin, you just add 273 to whatever the number is. So, if you have two examples here, we have 25 degrees Celsius. First, I add 273, which is our absolute 0. And then we get 298 Kelvin. And now you can plug that into your equation. So it's fairly simple. Every time you just add 273. So for 100, we add that, and it's just 373 Kelvin. I think I did the math right. Yeah, so we can apply that to our next objective. I'm going to find the molar mass after I first use the ideal gas laws. So this question, I got it out of the book. What mass of neon gas should be introduced into an evacuated 0.88 liter tube to produce a pressure of 90 kilopascals at 30 degrees Celsius? So, I'll write out our equation for the ideal gas laws. This is the ideal gas law. PV equals nRT. N is moles and R is the constant, T is temperature, and then pressure and volume. But when I'm working with molar mass, it's always going to be grams per moles. So I'm going to solve for N. So we divide each by R and T. And then this is what we're actually going to use right there. So I can plug these in. The moles of neon we have, is 90 kilopascals times the volume, which is 0.88 liters. And then, as I said before, R is the constant. When you're working with kilopascals, 8.314 is always going to be your R term. It's always going to be your constant. So, 8.314. And, as I mentioned, we can't use Celsius. We have to convert this first to Kelvin. So all we do is add 273, 293. No. 273. That's 303. Kelvin, not Celsius anymore. So, when we do the math, I already did the math, you're going to get 0.031 moles. And that's your ideal gas laws part. And then, to find the molar mass, which is grams per mole, you convert with crossing out your properties this into grams. So, we start with 0.31 moles of neon times, we're going to put moles on the bottoms and grams on top, so we get grams as our answer. and then we have 1 mole of this, and we use our periodic table to find the grams, which is 20.18. Okay. And then when we do the math, it ends up being 0.63 grams of neon. So that's the 2 objectives, and it's used all throughout Chapter 6. So I hope that helps.